Hello everyone. The another questions of work per energy, which will be the force F. F is the given and mass m is the given. Here force F is the variable because this force is the in the function of a time and mass m equals to 1 kg. Mass m is the constant. Then we have to calculate the value of power in function of a time. We have to calculate the value of a power in the function of a time. So we already know that the power P equals to F vector dot V vector. F vector dot V vector. Power P equals to F vector dot V vector. Okay. So F vector dot V vector imply that we can say we have already know that the force F and velocity V. Force F is the given and we have to need the velocity vector. Then we can calculate the power P. Power P equal to force vector dot velocity vector. Okay. So force F equals to T I cap plus T cube J cap. So this force is acting along the x-axis and y-axis. And this force is the variable force because this force is the depend on the time t. Mass m equals to 1 kg and power p, we have to need the power p in the function of a time. Okay. So trying to find out the velocity vector because force F is the given, we have to need the velocity vector. Okay. So we know that we have to need the velocity vector. Force F vector equals to mass into acceleration vector. Force F vector equals to mass into acceleration vector. Force F vector equals to mass into acceleration vector. Because Newton's second law says that external force is directly proportional to rate of a change of momentum. This is the Newton's second law. F external force vector is directly proportional to rate of a change of momentum d by dt of p vector. By experiment proportional removing the proportionality, then F external, which will be equal to k times of dp upon dt. Okay. By experiment, let us suppose k equals to 1. So p is the momentum. So we can put the momentum value to momentum p equals to m into v vector. So d by dt of mass into velocity vector. Let us suppose mass and velocity both are the variable. So we can differentiate d by dt of first into second. Imply that in this case mass is the constant. So we can say mass m into d by dt of velocity vector. Imply that we can say that number equals to mass m into dv by dt, which will be equals to accelerations. So force F equals to just mass into acceleration. This is the subset of a main number. This is not a perfect 100% Newton's second law. This is the Newton's second law. Okay. So F external vector proportional to the rate of a change of momentum vector, then directly proportional. This is the Newton's second law. So this is the if mass is the constant, then we can say F external vector equals to m times of a vector. Vector is the important number. So F vector equal to mass into acceleration vector. Acceleration, we can say that dv vector by dt. dv vector by dt. Okay. Mass is the constant. Then in place of a mass, we can put the value of m equals to 1. This is the given point. So dv vector by dt. Okay. We have to need the value of velocity vector. So we can say dv vector equals to f vector times dt. Okay. we put the f vector. F vector, what will be the f vector? That number is the f vector. So f vector is the t I cap, means t into dt, multiplying of the number of dt in force. Force is the given. Force is the t I cap plus t cube j cap. Okay. So t I cap plus that number into I cap plus next t cube into j cap, t cube dt, t cube dt into j cap. So dv vector equals to t into dt into I cap plus t cube into dt into j cap. Okay. Now we can integrate both sides. So if time t equals to 0, then velocity equals to 0. Okay. This is the given informations. Also, this is the given information. This, let us suppose that that particle is moved along the that particle is moved at any direction, but that particle initially start from the origin, and t equal to 0, and x equal to 0, and velocity vector equal to 0, because that particle is moved at the origin. Let us suppose, then we can apply that number. Next, at time t equal to t, then that velocity is the velocity vector. Okay. Initially velocity equals to 0. A final velocity, we can say that number equal to v vector. Let us suppose initial velocity equal to 0 and final time t equal to t. Okay. So integration of a dv, which will be v, then putting the upper limit, then v vector equal to this is the integration t into dt I cap, that number t square divided by 2. So upper limit is the t, imply that we can say t square by 2 into I cap plus t raised to 4 divided by 4 into j cap. So this is the velocity vector. Okay. Also we have to find out the value of a power p equals to force vector dot v vector. Force vector f vector equal to that number, then t into I cap plus that number t cube into j cap dot velocity vector. Velocity is the given, that t square by 2 into I cap plus t raised to 4 by 4 into j cap. Okay. So dot product of any two vectors, multiplying of I cap dot I cap. So I cap dot I cap equals to 1. Why you can say I cap dot I cap equals to 1? Because I cap dot I cap equals to I is the unit vector, so mod of unit vector, so angle between I and I equal to 0. So mod of any unit vector which will be equals to 0. Imply that 0 into 0 into 0 equal to 0. I dot j cap mod of I cap mod of j cap into cos of 90 which will be equal to 0, because I cap is the unit vector along x axis and j cap is the unit vector along the y axis. So angle between I cap and j cap which will be equal to 90 degree. So I cap dot I cap equal to 1. So t square into t cube divided by 2 plus t cube into t raised to 4, that number t raised to 7 divided by 4. So this is the power p is in terms of time t. Okay.